Yeah, so I guess you could trace the roots back to me being a Linux user, and at the time people were using Amazon Messenger or Windows Live Messenger on Windows, and I wanted to interoperate with that, and I noticed there was no client that supported webcam, so I started reverse engineering that, and then later ActiveSync when I was hacking on the SyncCE project because I had a Windows phone at some point, and during all this, I built some tools called OSpy, and that one kind of it was handwritten. Well, I wanted to observe API calls that were made in a black box application, and I wrote so-called hooks or callbacks that would get triggered whenever these functions get called, and then I could look at the arguments and so on. To help me understand, gradually build up an understanding. So reverse engineering basically is where I came from. Mm-hmm. But later I was also, as a developer, trying to, I observed something is that a lot of projects end up with logging systems. So this was more with a developer hat on. I saw another problem is you end up building a logging system for your application, and then you ship software to a customer. They have problems, and you realize you don't have logging to cover their problems, so you need to add some more logging and ship them a special build and so on. So it's a long feedback loop. And I was thinking it would be good if you could have a tool, you could have your tools work across different versions of your software, so you could maintain that separately. And you could do it like aspect oriented. You could just attach your hooks at runtime without having to recompile the software. And then also I saw a third kind of angle, and that was QA. So it's kind of cumbersome to have to set up a network environment for testing certain firewall conditions to see that the software is able to handle those. Of course, you have ways of dealing with that, but that's also another way you could also use instrumentation for that. So from the inside of the application, you can replace or you could get a callback when, for example, the application was to connect to a socket, and you could then just make it fail with econ refused, for example, to inject errors into applications without having to add mocks or like stub out things. So you could do like black box testing in very interesting ways. So there's the QA angle, there's the developer angle, and there's the reverse engineering angle, and there's the security testing angle as well, which is kind of what I'm focusing on now because I'm working for NowSecure, and we do automated testing of mobile apps. And first, as a concrete example, we do this on iOS, for example. When an app asks for the GPS position, we use Frida to replace that API call and just say, hey, yep, it's this location. And then we'll look in the network traffic and see if we see the same position that we injected. And if we see it there, it means it leaks. It has a privacy issue, and we can report that back in the test results. So there's like 4 kind of main use cases for Frida, basically.
Now, wait a second. Are you telling me that because I don't need to jailbreak my iOS apps, or I don't need to jailbreak my iOS machine, that I could use Frida to change my GPS coordinates so I could cheat at Pokemon Go?
Yeah, you could. Yeah, definitely.
Well, there's a use right there. Of course, for me, it's not Pokemon Go. You're never going to get me to play that freaking game. I'm too busy still playing Ingress and creating portals so they can use them in Pokemon Go. From what I understood, is Niantic seeded all the portals directly from Ingress. But anyway, so let's back up a little bit. For what I understand, and again, correct me if I'm wrong, the way this works is pretty phenomenal to me. You actually use tools to inject, is it like a V8 JavaScript engine into the target app, and then you tell that to be able to stub out or replace somehow the existing calls to existing, say, user application calls and also operating system calls?
Yeah. So the way this is built, it's highly modular. So you have a C library that's called the Frida GUM, which is like the instrumentation core. That knows how, at the lowest level, given an address in memory where a function is, give you a callback in C whenever that function is called. It can do other things as well, but that's like the core thing that this library can do. And then you have the higher level, we package that up into a shared library, and then we inject that into a running process. And then we establish a communication channel with it, and then we tell it to run pieces of JavaScript on V8 that it also has embedded there. These scripts have then have access to the full API of this GUM, this instrumentation core that I talked about, the C library. So you could use it directly from C just for instrumenting like a low level known JavaScript or anything, or you could use it like a high level, which is just this inside this other process, run this piece of JavaScript, and then you have a way to also exchange messages with it if you need to communicate with your agent running there. I call it an agent because it's to whatever you want it to do.